We're going to continue our discussion of basic graphs and today add the tangent of theta as a graph that we need to be able to come up with. And so we're going to start it as we did yesterday in the video where we looked at a table of values and we have theta and we have the tangent of theta. Unfortunately with the tangent of theta it's not as easy as it was with the sine and the cosine. Alright, so let's go ahead and look at the corners. Let's look at 0, 90, 180, and 270. Oh, let's put 360 in there as well and see what happens with the tangent. So we know that at the horizontal intersection points, the slope of the line is 0, and that at 90 and 270 at that vertical line we have undefined. And so this is going to be more of a challenge to graph, but I know you'll be able to do it. Let's go ahead and start it out. We have 0, 0, we have 90 undefined. When we have undefined in this, the graphic representation we're going to have at 90 degrees is an asymptote. All right? At 180, we have 0 again, and then at 270, we have an asymptote again, and then at 360, 0. All right, so I think you would agree this is not much of a graph. We need to add some things. So what should we add? Well, we all remember that at the 45-degree reference angles, the tangent is either 1 or -1. So if we add those, so let's go ahead and say in that first quadrant we have 1, in the second quadrant -1, third quadrant 225 we're back to 1, and at 315 we're at -1. So that helps us a little bit. So here's 45, I'm going to be at 1, and then I have -1 and 1 at 135 and 225, and then here I'm back to -1. All right, so it's still not much of a graph. So what we have to do is we have to go way back into this year and talk about graph behavior as a graph approaches an asymptote. Okay? And you may not remember this, but it's a really important thing to know, and that is that if you have an asymptote and you have a graph getting close to an asymptote, we don't ever just stop. We don't jump over it. We can only do one of two things. We can curve up next to it and approach infinity, or we can curve down next to it and approach -infinity. So we're going to use that idea and see that we're starting here at 0. We go to 1, and our only choice is to continue increasing without bound toward positive infinity as we approach the asymptote at 90. Likewise, that's going to happen again here, but then going the other way, we approach -infinity. All right, and so this, believe it or not, is a graph of y equals tangent of theta. And this is not one cycle. Remember when we talked about the cosine and sine, we graphed one cycle. This is not one cycle. This is just on the interval 0 to 360. Right? It also is periodic and it continues on forever in the x direction to the right and to the left, and so the domain and the range is a little trickier here, and so we'd like to say all reals, but we have those asymptotes, so we can't say that. So the way we describe this domain is we say x can be anything except pi over 2, and then 3 pi over 2, and then again there'd be another asymptote at 5 pi over 2. You get the idea. And so the way we write this, and you may have seen this before, is we say x not equal to pi over 2 plus pi k, and k is considered an integer. So k could be 1, it could be 5, it could be -20. All right, so that's the domain. And the range on this one, we can clearly see that the y values go from -infinity to infinity. All right, so some important things about the tangent. Just like before, we're going to get to class and we're going to practice them. So today's lesson, the other part of today's lesson, yesterday we only looked at y equals the sine of theta and the cosine of theta, and we looked very specifically at one cycle from 0 to 360. All right, so what we're going to do is we're going to change the x values of the graph. So we know y equals sine of x from 0 to 360. We're really good at graphing this from all the practice that we had before, right? So this is 180, 360. I know you could do it almost this fast, all right? But what about if I say on an interval, and let's say instead of 0 to 360, I want to go 0 to 720. Okay, how does that look different? Well, in 360 degrees, we can complete one cycle, and we just want to make sure that we get a second cycle in by 720. And so not only do we continue this for one more cycle, we have to find these values. So there's a couple of ways to do it. You can find the midpoint of 360 and 720, or you can just remember that every quarter of this cycle is 90 degrees. So this would be 450, this would be 540, 630, and 720. All right, so you see how we're changing things up a little bit. Let's do y equals the cosine of x, and let's change it so that we want to go from negative 360 degrees to 360 degrees, all right? And so when we're done with this, all right, we know we're going to go from 1 to negative 1. Did I include that on that? Yeah, I did. And we know what it looks like between 0 and 360 because we did that yesterday over and over again. But now we want to look and see what's happening to the left here. Well, if you think of it as reflecting across that y-axis, we see we get the same shape. Oh, that's not really the same shape, but close to the same shape of what went on here. And so if this is 180, this turns out to be negative 180. If this is 270, this turns out to be negative 270. And if this is 90, this is negative 90. All right? So these are just a couple of examples of different types of graphs we're going to play around with in class. The last one I want to talk to you about is, do you remember what it means to put a negative out in front of the function? And I hope you remember that this represents that the y values are the opposite, and the graph representation is that we flip over the x-axis. Right? So if I ask you to graph y equals the opposite of the sine of x, well, let's make it theta. Right? What that means is this used to be the graph, right? I'm just going to dot this in here. Well, it's not dotting very well. Okay? This means that instead of coming up here, we're going to go the opposite direction. Right? But the x values are exactly the same. Right? And the amplitude, let's see, is still 1. We travel as high as 1 and down to negative 1. All right? So that's what putting a negative in front of the graph looks like. And again, this is just one cycle. We want to always remember that this continues on in this pattern to infinity to negative infinity. Okay, great. Thanks for listening. We'll see you in class, and we'll do some more practice.